Hi, CS260. This is Professor Jensen, and we're going to be talking about WebSockets. So WebSockets is one of my favorite technologies, and it is implemented here between your front-end web browser and your back-end server. So normally at this point we've been talking about HTTP communication, which is initiated from your front-end browser, goes across the internet, and then is received by your back-end service to actually satisfy requests that are being made. What we want to do with WebSockets is make it so that either the client or the backend server, your front end or your backend service, can send data or initiate data requests back and forth across this. So instead of a line that's going from here to there, we can go in either direction. So let's take a step back and just look at what HTTP does to begin with. So in HTTP, by definition, the way Tim Berners-Lee set it up, it's always a client to server protocol that you're using. So the client, represented here on the left, will open up network connections, and it will make an HTTP request to do something like get scores. That will get sent to the server will receive that network request, process whatever getting scores means, and then respond back with the result, which is in this case the scores array. So HTTP is always client to server. This becomes a problem when you actually want to send data from the server. So the only way that you can get around that is to make it so that the client is continually pinging the server like, hey, do you got some more data for me? Does something else happen that I should be aware of? And it's just going to be doing this all the time. And that's the way it was done for like over a decade. They call that long polling, and to be able to receive that information sent from the server when the client didn't actually know whether the server had it or not. So to make that more efficient, they actually introduced the WebSocket protocol. And they introduced that protocol to sit on top of HTTP, and this is how it works. So the client initially makes an HTTP connection, just like it does historically, but it will specify two additional headers within that. So it's saying I'm making an HTTP request, but I want to be able to upgrade that request on connection to a WebSocket protocol. So when the server receives that request, if it can handle the conversion to a WebSocket protocol, it will return back that like I have upgraded your connection to WebSocket, and this connection has now been upgraded, so it's done. And from that point on, it's no longer an HTTP connection. It's actually an upgraded protocol using WebSockets to actually send data. And either side of that peer connection, because it's no longer a client-server connection, it's a peer-to-peer connection, can originate requests and send data back and forth. So this is demonstrating that now on the right side, which was before your HTTP server, is now a peer connection. And to send a ping over like, hey, are you alive? And the other peer will send back, yep, a pong, yeah, I'm alive. Or it could start on the left and go ping, are you alive on the right? And the right would respond back, yep, I'm alive on the left. Now, ping and pongs aren't very interesting, but that's actually part of the protocol itself. Ping and pong is put in there to make sure that both sides know that the other server, that the other peer is actually listening and connected to that. So if something happened with the network or one of them died, the other side of the peer connection would be able to detect that that's gone and close their side. So a normal connection would be initiated from either side, or a normal communication would be initiated from either side. So the one on the right could say, hey, how's it going? And the peer on the left doesn't have to respond. They can just ignore it. So the peer on the right can say, hey, you want to hear a joke? And the peer on the left says, only if it's good. And that communication goes back and forth with either side initiating and responding to what the other peer has said. In the end, somebody says, okay, I'm done. I'm going to close this connection. That gets sent over to the other peer, and the peer responds with like, okay, great, I've closed the connection too. And that makes it a bi-directional communication using the WebSockets protocol, which is much more powerful than it is with just HTTP. So you might ask the question, well, why isn't everything WebSockets communication? And their answer to that is because there's a whole lot of infrastructure out there with routing servers, with browsers, which expects to be using the HTTP protocol. And so WebSockets is generally only used when you want to push something initially from the server up to the client, or if you want to make a very fast real-time kind of communication back and forth between two peers. It also allows you to create a situation where you can have multiple clients out there that are all sending information to a server, and the server proxies or propagates those events to all the people who are connected to it. So it kind of becomes like a chat server kind of representation. And that's a really good fit for what you do with WebSockets. So you've already experienced WebSockets before. And you'll see this in the live server extension that we've been using for a long time. You didn't know you were using WebSockets, but that's how it does its hot reloading. If you notice, when you have that extension up and running, it would automatically push events from the editor, the Visual Studio Code editor of whenever you edit the file. It would push an event up through the server to the browser, and the WebSocket code listed there would say, hey, there's been a reload of that data there, and so I'm going to refresh it. So we can demonstrate this if we just go out to Visual Studio Code and create a file and watch the actual WebSocket communication going back and forth there. So I'm going to go over to my console. I'm going to make a directory called VS Socket demo. Then I'm going to change directory into that VS Socket demo directory, and I'm going to open up Visual Studio Code. And I've already got my live server extension going here. And so if I don't have it running, but I've got it installed. If I go ahead and create an index.html file, and then just blow in some simple HTML here, and we'll go ahead and put in our body of, like, put in a header here and say, hello, something like that. And then if I push the live server extension button, that's going to set up an HTTP server. And as we saw there, it's actually listed on port 5500. And if we come over here, it also launched the browser window for me, and it's talking on port 5500 to actually display that text that we saw there. So if I open up my dev tools and we go to our network tab and I refresh this page, you'll see that there's actually two requests that are going on here. The first one is that there's a request to get the HTML page, which is what we actually requested. And if we actually look at the code, it's a little bit different than the code that I actually wrote in the browser. In the browser, it's just a simple body with the h1 hello in it. But over here, I've got my body with the h1 hello, but the live server extension injected this whole JavaScript block here, which is doing our WebSocket communication. And so that's initiating another request, an HTTP request, which gets upgraded to the WebSocket protocol. And if I look at the messages that are going on here, I'm actually getting a connected message coming back from the server, or you're pushing that down from the client that they've actually connected to the server. Now, if I go back to Visual Studio Code, and I'm left my preserve log on here, so I'll be able to see what requests go back and forth between requests when I actually do a refresh. And I change this to be like hello WebSocket and save that. The Visual Studio Code live server extension is going to detect that that file has changed here, and it's going to use that WebSocket connection to actually push new data up. So I had my WebSocket connection made up here, and if I actually go and look at what happened after my connection was done, you'll see that there was a reload event that was actually pushed up from the server and told the browser to reload. And if we look at our source code, over here on index.html, you can see that that's happening here because it's listening for a reload event to be sent as the data over the WebSocket. And if that happens, then it's going to actually call window location and reload. And that's going to force the browser to go back to the server again and request that HTML page again. And that will then create a new WebSocket connection, which is just sitting there waiting for things to change. So there you go. You've already seen this, and you can see the source code within the Visual Studio live server extension on the client running to actually do the WebSocket connection. And we can't look at the back end of that without actually going in the source code from it. But this is just to demonstrate that you're already benefiting from the use of WebSockets to get a hot reload in your browser while you're developing things. And that's a great example of what you can do with WebSockets. So let's go ahead and write our own WebSockets, client and server. So what I'm going to do here is I've got some server code, and you can see it's just a few lines of code, but that's really all you need to actually do a server. And then I'm going to go back over to our source here, and instead of this representation, I'm going to just delete this file here. Well, we can leave that file, it's not going to hurt anything. I'll create a new file, which is index.js, and I'm going to paste in here the code that we need to actually make a WebSocket connection. Now, this is requiring a package, an NPM package called WS, which is for WebSockets, which implements all the networking, upgrading, and so forth to make the WebSocket network communication happen. That's all written for you. You don't have to worry about that unless you really want to dig into network protocols and see how that's all working. So to make that work, I'm going to have to go ahead and install that package. So I'm going to come over here and I'm going to do npm install ws to install WebSocket. And now I'm going to have a package JSON file with that dependency for WebSockets, and it's imported that code into my node modules. So that's there. Then the next step is to use that class that's returned there and actually create a new WebSocket server. And for this simple example, I'm actually going to have it listen on port 9900. So it's going to set up its own HTTP server listening on port 9900 for an upgrade to actually happen. And whenever a connection is made on that, it's going to handle the upgrade from HTTP to WebSockets for me. And then I can register an event handler that whenever a connection is made, that this function right here, this arrow function, is going to get called on a connection event to my WebSocket server. And that's what the WSS stands for, WebSocket server. And that WebSocket service connection is going to give me, or that WebSocket server is going to give me a WebSocket object which represents the connection, which I then register another event handler on it for any messages that come across on that WebSocket connection. I'm going to get the data that's received. I'm going to convert it to a textual representation. I'm going to console log that out so I can actually see it happening on my server side. And then I'm just going to send back a response that says, hey, I heard you say something. And that's the kind of just pinging back. Exactly. It's a parrot kind of action going on here. You say something, I'm going to tell you you said that. And then in addition to handling messages on that connection, I'm going to actually just do a simple send to whoever's talking to me, my peer, and say, hey, hello, WebSocket, I heard you. And so that's basically the entire server. We bring in the package, we create a WebSocket server, we tell it that we want it to write an HTTP server that'll handle our upgrade automatically for us, and we're going to create a connection. We're going to create a connection handler, and whenever we get a message on that, we're going to handle that with this function right here. And then we'll send a parroted response back for messages received, and we'll also send an initial message when that first connection is made. And that's the entire server. Okay, so if we go back over to our browser code here, and we look at the next one, we'll see that we've actually got a browser representation. So I'm going to copy this code and pull this up. So if we've got to start up our server, so I should be able to use F5 to start a debugging session for this index.js file, and I'm going to attach it to my Node.js program, and then I can do something like set a breakpoint here. So whenever connection is made, I want to stop on this here. And then whenever a message comes out, maybe I want a breakpoint there. So that's up and running. You can see that the debug console window says that's good. So I just need to write my client. And we can do that in any browser window we want, because I'm just going to use the DevTools console to actually plot my code in there. So I'm going to go over to the console here. I'm going to do clear all that stuff. And I'm going to paste in the client side of creating a WebSocket connection. Now this is even simpler. So I can use the built-in JavaScript library of API for WebSocket, tell it the host that I want to talk to. So I'm using the WebSocket protocol. I want to talk to myself on my own server on port 9900, which is what we were listening on over here, 9900. And then I'm going to, when I receive a message, I'm going to just print out whatever gets sent to me. So whatever my peer sends to me, I'm just going to print it out. So I should be able to run that. You notice that hit my breakpoint back on my back end on my server, and it's saying I've got a new connection coming in here. And that's great. So I'm going to just push F10, and then I'm going to send back to the person who created it the fact that I actually heard them. I'm going to take my breakpoint off here so I don't hit that again. I push F5. And if I toggle back over to my client, you can actually see that I received that message right there. So that came in, and I printed out that. And now I can send things too. So I can, over that socket that I created, I can send something like, this is a great demo. And send that message there. And you'll see I hit my breakpoint on my back end that a message actually came in. And if I push F10 to actually decode what that information was from the binary representation to a textual representation, you can see that I've got, this is a great demo. And I'm just going to log that out. That gets printed out there. And then I'm going to return or send back that I heard you say whatever you said to me. So I'm going to take my breakpoint off and just go ahead and push F5. We toggle back over our client. You can see I got that received. I heard you say this is a great demo. And I can play this game all day long. So I can say, echo, and it's going to respond back to me echo. And that's all it's doing. It's just parroting back. But you can see with those simple, 5 lines of code on the client and a simple 14 lines of code on the back end, that I can actually do bidirectional communication now. And either one of these sides can actually send data back and forth however they want. If I actually went over here and stopped my server and do a sent interval. And we're going to put in a function here. And we're going to just do a WS send. And I'm going to do like, tick. I'm going to just send out a tick. And I'm going to do this, every, 2 seconds. If I save that, and we actually move this up into our code up right here. So we don't need to send the hello I'm connected anymore because our tick will just go ahead and push that out all the time. And then I start that up again. Code always seems to be running. I'm going to reconnect my connection on this side here. And every 2 seconds, if I got that right, you can see that the server is just pushing data up to me. Tick, 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 and I'm getting one of those every 2 seconds. If I go over to my network tab, I can actually see that I have this connection going on here, and you can see those tick events actually coming in, or those tick messages coming in from the server. And I can go back to my console, and if I do a socket send, I can still send my messages from my front end to my back end, so from the front. And that's going to get sent, and I'll get back my message from the server there. But if I go over to my network and look at it, I'll see that I actually sent from the front end, from the front, and then I got back the response from there. So that shows you, initiated from the client, initiated from the back end, and then being able to send whatever you want events back and forth between the two. And with like 20 lines of code implementing both the front end and the back end of that. And that's pretty cool. I think that's like a very accessible technology. It leverages standards, so it uses HTTP, which everything supports, and just piggybacks on that to create a more powerful standard protocol, which allows you to do not just client to server requests, but allows you to do bidirectional requests. So let's go ahead and see what's next in our slides. So let's take it to the next level. Let me go back over here first of all and shut down my server. So I'm going to do Shift F5 to shut that down so that we're not ticking all over the place. Then we'll go back over to our slides, and we'll see our next step is to actually create a chat application. So far we've seen clients sending messages over WebSockets to the server sending messages back to the client, and now I want to demonstrate what happens when you actually have multiple clients and they're proxying their requests through a central server. So we're going to create this right here, this chat application where you've got John, Ringo, and Paul all chatting back and forth with each other. And you can play with this yourself if you go to chat.cs260.click, and you go ahead, and we're going to pull this down so we can see multiple of these. And I'm going to say, I've got John listening here, and I'm going to duplicate this and create a second one. And so I've got Ringo here, and Ringo says, when are we going to play again? And he sends that, and you can see automatically in real time over here on the left-hand side that John was able to receive that communication from Ringo, and he says, in heaven will be the next time we play, and he sends that back. So the WebSocket connection is actually modified and displayed there by that line, but then you can see those communications going back and forth between them. And we can create as many of these as we want. So if we want to add another member to the band, so Lee's going to join the band, and he says, I'm ready right now. Then I'm going to send that, and you see how it propagated to both John and Ringo, that Lee is now ready to join the band. And that creates just a very simple chat application. So you're probably wondering, well, how does that work? How can I actually make that within my code? And it's not much more difficult than what I've already demonstrated to you. So I'm going to close all those up. And we're going to go and we're going to grab the chat code from the class GitHub account from the WebSocket chat repository. So if I go back over to my console window, change out of our demo directory, and then I'm going to paste this in here to clone the WebSocket chat program, which has all the code necessary to do that demo that I just showed you. And change into that directory. Looks like we already have it, so we'll just use that. And we'll bring up Visual Studio Code to actually show what's going on here. So I'll close down our old example here, just for clarity what's going on. And we'll bring up the WebSocket code. So this has a couple parts to it. There's a index.js file, which is located here in the root of the project, and that has our backend server code for actually displaying the functionality. And then there's also a client, chat client, which is in our public directory, and that's our JavaScript on our front end to actually receive and display the messages and just send new messages to it. So let's look at the backend code first. And you're going to notice right away that this code is very similar to what we had within our simple demos that we showed you so far. There's one major difference though, and that's we're no longer telling the WebSocket class to actually create our HTTP server for us. We're going to actually explicitly do that ourselves by creating an Express application, which will create our HTTP server, and then we're going to upgrade HTTP requests that come for that server to actually be WebSocket requests. So those are our two packages that we're bringing in. We're bringing in the WebSocket package, and we're bringing in the Express package. We also create our static middleware so that we can load up our HTML client on the front end there, and I'll show you in a minute. And then we start up our HTTP server just like we have done in previous examples, defaulting to port 3000 in this case. Then the new thing that we introduce here is we create a WebSocket server. But instead of like we did before, where we specified what HTTP server we wanted it to create for us, we're going to say we don't want you to create an HTTP server. And so we just give it a parameter of no server true. And that sets it up so that we can actually do that protocol upgrade. If we go back over to our slides and go back to here, this is what we're actually doing with it. We're taking it from an HTTP request, we're upgrading the protocol, and then making it so that that connection is from that time forward a WebSocket connection. And that's what's happening here. So that server, our HTTP server, when it receives an upgrade request, it calls this callback function, which calls into our WebSocket server and tells it to handle the upgrade from HTTP to HTTPS. And then it just emits a connection event that lets everyone who's listening on that connection know that that's actually been done. And those three lines of code right there do our complete upgrade from our HTTP server to our WebSocket server. Then our code really is simple. I've just got this connection array, which is just a global variable for our JavaScript backend. And I'm going to stick in every WebSocket connection that is made to the server in this array. And I'm doing this so that when I receive a request from one of the connections, I can propagate or send that back out to all the other clients, front ends that are listening for those chat messages to come through. So that's what that array is there. Then I just listen for an on connection event to happen. I stick that connection, including its WebSocket connection, into that array up here. And then I listen for new messages to come in. And whenever a new message comes in, I just iterate through those connections. And if it's not my connection, the one that's actually receiving it, then I send it out to all the other connections. So envision in your mind, you've got the three different chat windows there. One of them, Ringo sends it, and John and Paul, and Lee, of course, is the new Beatles member, is going to get all of those messages sent to them over the WebSocket connection that they created when they connected to the backend server. So that right there implements basically the entire chat functionality on the backend. There's a couple other things that it does. So first of all, if we ever close one of our connections, we want to make sure we pull it out of our connection array so that we don't keep trying to send it to somebody who's not listening. And we also implement the ping and pong protocol so that if there's a large lull in the communication between our clients, that we don't close down those connections from the back end. So the way we do that is I use the set interval, and every 10 seconds I go through all the connections and I check to see if they have previously been marked as not alive and they're still not alive. So if they're not alive after 10 seconds, then the client has gone away and I'm just going to terminate or close that. Otherwise, if they are alive, then I'm going to mark them as not alive and send a ping message to the client. So every one of those clients is going to get a ping request, and they're going to turn around if they're listening and send back to me a pong request. And if I get that pong back, then I mark that connection as being alive. So if everything works right, everybody who I'm connected to gets a ping message. All of the front ends then pong back to me, and on my back end connection array, I mark each one of them as being alive, and that way I don't terminate them the next time my 10-second loop comes back around again. So this line of code right here are all just to handle that ping and pong. If you leave it out, it just means that if there's not data being sent back and forth, then either the browser or your server will just randomly kind of close those connections and they won't be available anymore. But with that in place, they should stay up for a long time. unless there's actually a real network problem or something like that. So close, ping and pong, and then here's our actual functionality for actually forwarding those chat requests back and forth with it. And that's our entire back end. Really simple. We've just got 66 lines of code to actually implement a chat server on the back end, which is pretty impressive. Now to make it work on the front end, remember we've got the Express middleware hosting up our public directory. So if we go over to our public directory and look at our index.html, I've got some simple controls here for actually implementing the chat application. So the first one is that I've got to place an input for my name. I've got an input for a new message that has been sent, and I've got a button that allows you to send it. And then I've just got this placeholder div where I'm going to inject all the messages that actually get sent. And then finally, I load up the client chat application JavaScript so that it actually creates that network connection back and forth. And if we go look at that code, we'll see that just globally, when it loads up, it's going to create that connection over the WebSocket. Now it does something a little bit different than we were seeing in the more simple example before. It actually looks at the current protocol of the connection that was used to load the HTTP page that we're rendering. And if that is an HTTP connection protocol, then it's going to use the non-secure version of WebSocket, which is just WS. If it is a HTTPS or a secure protocol connection, then it's going to use the secure version of WebSockets, which is actually WSS. And so then it creates our WebSocket, uses that protocol based upon the secure level of our HTTP connection to the location that we were already talking to for getting our HTML file. And then it's going to say, I just want to create a WebSocket connection there. Then it's going to actually open up a connection over that socket. And when it actually receives that, when it receives the on open event for that, it's going to append a message to the display that says, this is the type of message I got, this is who sent it. In this case, it's the WebSocket, so it's just a connection and what that event was. So if I go look at this function here, all this is a DOM injection. So it's just query select for that chat text div element, and it's blowing in inner HTML on top of or before the HTML that was previously there. And that's all append message does. And we use that several times in here to actually update the actual UI. So that's what happens when it opens. Now we also register an on message handler. So whenever we get a new event of a new message coming in, we convert that to text. We parse it from the text to JSON because we're going to be sending from the JSON to a JavaScript object because we're going to be passing our data back and forth as JSON. And then we pull out the name and the message that was sent over that WebSocket event, and we say that it's a class of type friend that's actually sending it. If we ever close, then we disable our commands. If the server shuts down, we don't want to have our user thinking they can continue to send information there. So that's why we disable the controls. And then whenever we want to send a message, so we implement a send message that our front end HTML can actually call. So you can see on click, we're calling send message. That calls into this function here. That sends it, and all it does is it pulls the message text out of the new message, and it appends on that message to the display into the DOM that I just showed you a minute ago. And then it pulls out the name of the person, and it uses a WebSocket send to send the name of that person plus the message they had to actually send it across. And that's the entire front end code. You've got something to send the messages. So let's see if we can make this work. So if I come out back here to my back end code, and I've already done an import, so I brought in my WebSocket and my Express packages. You can see I've got the node modules there. So I should just be able to push F5 to start up debugging. And you can see I'm listening on port 3000. And because I've got that static handler there, I can now go over to my browser. And I can go to localhost 3000. And I should see my chat client actually popping up here. So if I bring open my network window and I refresh this, you can see that not only am I getting my HTML coming in here, but I'm also creating my WebSocket connection. I haven't sent anything back and forth over yet, and I'm bringing in my chat client JavaScript file here. So now the next part is to actually make it work. So let's pull this out, and we'll create a couple of windows going on here. So I'm going to leave that one there, and then I'm going to open up another document and stick it over here on the side. Yeah, there you go. Okay, so I've got 1, 2, and I can say over here, my name is Tina, and I'm going to say, hello, and send that. And you can see over here on this side, even though this user hasn't identified themselves, they're receiving that notification coming across here. And then I can go ahead and put Bud in here and say hello. Oops. Say hello, Tina. Good to meet you. And push enter, and that will send across. And you can see I've got my bidirectional communication going on there. And it's working the exact same way that I was showing in that more simple example. We can go ahead and set breakpoints if you want, but the interesting thing that's happening here is that WebSocket communication. You can actually see the messages being received, and the messages being pushed up to between the two peers as proxied through our backend service. So Tina can say again, you're going to say Yahoo, and send that, and you can see that you actually got a binary message coming down here, and that gets interpreted, converted to text, and then displayed here. I'm going to say, this is fun. We can do this all day long and see those messages going back and forth between it. So it's now created a peer-to-peer kind of relationship between our front ends. They're not talking directly to each other through WebSockets. They're proxying through a server to actually send those messages back and forth. But that's way cool. Just with 57 lines of code on the back end and another 50 lines of code on the front end, you can actually build a full-on working chat client between browsers. So if we wanted to debug the back end a little bit, just to kind of close the loop here, we can see that when our messages come in here, I'm going to put a breakpoint on this here. And if we send one more message from Bud for new, you can see my breakpoint hits. I'm going to get that data, and that data is, it's a byte array, it's binary at this point. But I'm just going to loop through every one of the connections I have, and I've got two, I've got those connections there represented. If I then step through it by pushing F10, I'll see that that's that one, and then you get the other one here, which is Tina coming through, and you're good to go. And it's just sending those back and forth there. So that's debugging on the back end to help you know what's happening on your server, and you can debug it too on the front end if you come over to the sources and bring up our index.html or our chat client.javascript. You could debug it here too if you wanted to. So if you got whenever a message comes in, you can put a breakpoint here, and over here it can say Tina now says hello and sends it. You can see over on Bud's side, he's receiving it, and we're going to convert that to text. If I push F10 or push F8, oops, if I push F10, if I remember my keystrokes, just F8. Oh, sorry, I already ran it. So if I push a message here, we'll do that again, say hello. Then you can see I broke here. I push F8, F10. Then you can actually get the text coming out of there. That's coming from Tina and hello, convert that to an object, and to be able to then just call into our append message function, F11, and see that I'm just taking that chat text and blowing it into our HTML. So I'm going to go ahead and push F8 now, and you'll see that it actually runs. So that's the demonstration of the chat application. So I can close those up, and we can move on from there to actually show our next step, which is to actually make this work within Simon WebSocket. And what you're going to see here is that it's not a whole lot different than that chat application we just ran. With Simon, I intentionally made it super simple so that it would demonstrate the important parts of WebSockets without getting overwhelmed with application functionality, getting in the way and obfuscating what's really important and what's happening there. So if I go to Simon-WebSocket here and pop this out and open a duplicate window of this and pop it right over up. Pop that over here, toggle between all of these ones. There we go. Then you can see I'm logged in both places. That's actually not good because Simon does actually keep track of cookies, and it knows who users are and stores things in local storage. So I don't want to use the same window in both of these cases here. So I'm actually going to open up a new incognito window in this case. And we're going to close this one. And we're going to go to the same place. So we're going to go to Simon-WebSocket. And now we're good. It doesn't know who I'm actually logged in as. So if I go ahead and play the game here, by pushing this, and I come over here and we'll create a new account. So this is Tom, and we'll give him a password and create a new account. Then you can see that they're both connected. So that indication there is that the WebSocket connection is actually working right. But if I reset over here on the lead side and start up a new game, as soon as that game is actually created, then you're going to see that the new game was created on this side over here, that they got that notification and everything is cool. So if I go ahead and play the game and get it wrong, then you'll see that that Tom actually got a notification that a new game was started and that Lee scored 0 on it. So you can see that it's using that to propagate the events and get people excited about, hey, you know, Lee's playing the game, you should play too, and see if you can beat his high score or whatever it is. Admittedly, it's a very simple example because I really wanted to keep that super simple and not make it too complex so that you wouldn't be able to see how the WebSocket stuff is working. But hopefully you can look at that and see that, oh, okay, I can push stuff out. So for example, if I have stock tickers or something in the background, or you've set alerts that you want to be notified on your front end, and the back end knows that the front end is connected, then it can send those alerts and those notifications up there. Or you can do a peer-to-peer kind of thing where you're sending data back and forth through your server to actually make it work on both sides of it. So that's how Simon as an example works. If I go ahead and close that up, we can go look at the source code for Simon. Let's go ahead and shut down our chat program, go off to our console window, change directories, and we're going to go into our, so we don't have that one yet, so we're going to do a git clone, and instead of the WebSocket chat program, we're going to bring in the Simon.WebSocket repository. So I can change into that, Simon.WebSocket. I'm going to do an npm install because we just pulled the code down. It doesn't have all the packages yet. And then I'm going to open up this code in VS Code. Now what you're going to see here is this is going to look very much like the chat program because it basically does chat. It's just you don't have a user actually inputting what the messages are. The messages are generated based upon what the user is actually doing in the program. So the interesting part on the back end is here in this peer proxy code. And we've got just about 61 lines, which is about what we had in our chat program implementing that peer proxy. So we do the same thing. We bring in the WebSocket package, and this time I'm actually bringing in the UID package because I want to create a unique ID for each one of the connections. So I'm going to use that there. But then this code gets started up, so it gets past an HTTP server, and it attaches, just like the chat client did, the WebSocket handling code, the WebSocket server, to that existing HTTP server. So we're going to tell it we don't want you to create your own HTTP server. We just want when that HTTP server receives an update request that we handle that with our WebSocket server that we created right here. And then we've got our connections array, just like we did in the chat program. And whenever a connection comes in, we're going to create a new connection using that UUID generation. We're going to say it's alive currently, and then we're going to remember what that WebSocket connection object actually is. And we're going to push that onto our array of all our connection objects. Then we'll handle messages that comes in, and this looks just like the chat client. All it does is just spin through, and everyone that's not me, I'm going to send that data off to all the other connections. We handle close, we handle our ping and pongs, just like we did in the chat. So pretty much the chat program right there. The one different thing is that in the chat program, we were creating our Express HTTP app right in here. Instead, we do that in our index JS file so that we can set up all of our endpoints and our middleware there. And then at the very end, after we've got that whole HTTP server all set up, we just call into that peer proxy code that we imported up above right here. Peer proxy code using the Node.js require import syntax. And we pass it our HTTP server so that it can attach our WebSocket server whenever an upgrade actually happens to it. And that's the entire backend server there. If we go look at the public code to actually implement the front end, most of that code happens here in our play.js because that's where we're actually displaying and generating our events. So you'll notice that in the case where you start a new game, so when you push the reset button, it does this new thing here where it broadcasts an event that this player has actually started a game. And if we go and look at the broadcast event function, you'll see that it's creating an object and then it's sending that object over our socket. So where did the socket actually get initialized? Well, we do that when the constructor is actually started up. We call this function called configure WebSockets. And if we go look at that function, you'll see that it's doing that same game of using the secure protocol based upon what the HTTP protocol was. We open up our socket, we handle the close event, and then we just process these messages here. And all it's doing in these messages is very much like the chat program. It's just instead of calling them append message, it's calling this function called display message, which just query selects out of the DOM this element and then slaps on new HTML there to actually display what those messages are. So very similar to the chat program. The only other real thing that's going on in here, if we look at broadcast event, we'll see that it's called when you reset the game, but it's also called whenever you save a score. So when the game is over, we pass on the information about what happened in the game, what the score was, the new score, so that all the other game players in their browsers can see what this user actually created. So that's your front end code, and that's pretty much everything. It's once again not more, both in your front end and your back end, to actually create like a full-on notification of people playing games and how they're doing with just like 100 lines of code. So what you should be able to do from this is study the very simple case. So within your browser, just set up a server, a little backend that sets up that WebSocket just like I did initially, and then take it to the next level and go grab the chat client code and bring that down and get that running and breakpoint through that and see how that works. And then the next level is to get the Simon WebSocket code and get that running, put breakpoints on the front end and the back end, and debug through that and see how that works. And once you've done those 3 exercises, you should be pretty comfortable with taking what you've learned from that and implementing it into your startup. And you can do that whatever makes sense. If you want to do a simple chat thing, that works great. If you want to push events from your server up to your client, that also works great. Just make sure that you've got both the client and your server registered and handling WebSocket events, and then you're good to go. So with that, we're pretty much done here. We can just come here, give you the shaka. Glad to have you here, and we hope that you have a lot of fun implementing WebSockets in your startup application.